Yeah, I can hear you. So I'm the author of the paper RANPilot. It's the third paper in the RAN and cellular system section. So if you have any question, you can share your points and I will answer your question. Yeah.
I have one question from Vietnam.
So maybe the internet is not that good. So
Yeah.
can you repeat your question?
So one question from the Vietnam Post. Can you hear me?
Yeah, I can hear you.
Okay. Thank you for the interesting presentation about the RANPilot. So I have a small question. So RANPilot depends strongly on representative SIGCOMM. So how can the system determine before development? How can the system determine before development? Available seats, available speed, representation for planned reconfiguration. That's a small question only.
Sorry, can you repeat your question?
That's and how can the system determine before the development?
For improvement.
Development. Whether available seats data are sufficiently representative for the planned reconfiguration.
Yeah, reconfiguration. So what's your question?
The question is how the system determine before development. That's the ACM is already data after the development phase. That we will have already the data for processing this.
Yeah, you mean how can we ensure the?
Yeah.
Let me try to repeat your question. Do you mean how to ensure the synthesized data can represent the system status of the after the reconfiguration? Is this your question?
Yes, correct.
Yeah, of course. That's a very good question. Actually, in our paper we have some discussion about the data fidelity. It means how well the synthetic data can represent the new system and how well it can approximate the data distribution in the new system. So it actually depends on several factors. For example, of the cellular system is very challenging. So we have in our implementation we have a seed KPM, which is the real KPM treated from the old system. So if we if the seed KPM is comprehensive enough, it means it can capture the environmental complexity of the old system. And after the virtual RAN synthesis, which means we use a virtual system to bridge the data set from the old system to the new system. The only changes occur in the RAN system side, and the environmental complexity remain the same. In such cases, we can integrate this expert knowledge about the RAN control policies and RAN system changes to the synthetic data. But another case is for some kind of system changes, the new system has completely different environmental complexity. Like if we move the cell site if we move the cell tower to a new site, or something like this. If the system changes happens when the user traffic and user behavior changes a lot, and the seed KPM traces are not representative enough. In this kind of cases, the synthesize would fail because there are a lot of external factors beyond the system changes themselves. So in these cases, the data synthesis may be not that effective. You can refer to our evaluations in our paper. Maybe I remember it's the figure 12. Yeah, we have 6 figures representing different kinds of reconfiguration types and deployment scenarios. Yeah. Am I clear for this question?
Yeah. Thank you very much. I leave us time slot for the other. Thank you.
Oh, thank you. So, do you have more questions for my work?
Can you hear me?
Yeah, I can hear you.
Okay, hello. Hi. Hi, I have a couple of questions. So my work is
Yeah, of
adjacent
course.
to
Oh, sorry, I cannot hear you now.
Hello? Are we
Yeah,
good?
yeah, I can hear you now.
Okay.
Yeah,
Okay, mic test. Okay. So,
yeah,
I have a couple of questions. So my work is adjacent to yours, but oh,
yeah.
the
Well, I can.
reconfiguration.
Yeah, keep going.
Okay, I think this is better. Okay. So, uh, so my questions are along the lines of reconfiguration. So I saw the other questions that they asked you during SIGCOMM, and most of the reconfigurations that you mentioned are on the cell reconfigurations, right, or cell parameters, right? But what
Yeah,
if the
yeah,
reconfigurations are, let's say, on a wider scale? Let's say, for example, network slicing, or let's say ORAN splits, or let's say VNF placement, right? So does your
yeah.
model, you think it's extendable to for synthetic data generation when it comes to those other reconfigurations that you did not mention? Or well, I read your paper, it's not really in that
Yeah,
context yet.
yeah, yeah. Of course. Thank you for your question. It's a very good question. For the reconfiguration, like the RAN slicing, if we change the slice strategies, we may change the allocation strategy to different user equipments. So actually, it is also related to the application layer, like the specific application the UE are operating. So for this kind of scenario, it is hard to be captured by the operator, you know. So it's actually not the scope of our reconfiguration. Actually, we mainly target the RAN side, the infrastructure side, not the application side. So, but your question is a very good direction for our future exploration. If we can like to accommodate this kind of user side application level shift and capture the changes, and if we can adapt the model to proactively adapt to different kinds of user side application shifts. That's also a promising scenario for future direction, but not currently covered by our work. Yeah. Thank you for the question.
Okay. You mentioned infrastructure, right? What about, let's
Yeah.
say, you are aware that ORAN VNFs have different splits, right? Like split 7.2, split 8,
Yeah. Yeah.
other splits, right?
Exactly.
So, and also in the context of VNF placement, like, you know how CUs and DUs are containerized, like SRS and OAI, right? If you have
Yeah.
different, let's say, locations like in the edge, does your work or is your do you think also that your work is extendable to that framework?
Yeah, it's extendable because we have the interface model, we have the wireless channel model. They can be applied to different 7.2 or 8 split. We just like to update the model to fit that kind of specific scenario or standard. Um, um, I don't think that is a huge roadblock for the data synthesis. Yeah.
Okay, last question. Sorry. Okay.
Yeah, of course, of course.
You think that so your model is able to predict, right? And it tries to keep those AI models. So let's say QoE prediction, anomaly detection,
Yeah,
right? So
yeah,
uh, do you think or is your work extendable in the context of closed loop control? Because I assume that
yeah,
for anomaly detection or QoE, they
yeah,
predict,
yeah,
right? So
yeah. Yeah. Oh, that's a good question. We have a discussion about how to integrate this AI into the data synthesis loop. Actually, maybe I remember is at the end of the virtual run subsection. So we have a reinforcement learning module. It is integrate, but I mean the run control action itself is integrated in the data synthesis process and in the loop. So you can refer to that part of the context for your answer. Yeah.
Okay, thank you.
Yeah. Thank you for your question. It's my great pleasure.
So we have some questions.
Good morning. This is from Bangkok.
Yeah.
I
Yeah, of
have
course.
a question about the RANPilot. Can RANPilot determine which types of configuration are worth proactively adaptive to, and which ones are minor enough that the existing model can continue to be used without adaptation?
Oh, you mean what kind of reconfiguration needs the data synthesis, and what kind of reconfiguration can be easily handled by the continual learning, right?
For example, if this situation is if the configuration is very good, the RANPilot will adapt or not, or we use the
Thank you for your question. I get your point. So actually, RANPilot does not actively reconfigure the network. It is a framework that helps the operators to have a smooth AI performance through their operator-initiated reconfiguration. So actually, it had to be triggered by an explicit reconfiguration plan. Means the operator have to tell the system, tell the RANPilot how they want to reconfigure the network and what's the specific changes. For some minor changes like that, we just tune the gain or like or just slightly modify the software policy, the parameters in the software. It is not that this kind of reconfiguration do not introduce significant data drift. But for example, if we change the topology with cell addition or completely add new features for the radio control policy or for something like this, we have completely new network behaviors. For this kind of scenario, we must use some technique to bridge the gap. So RANPilot is one of the technique. We use the synthetic data to tune the model. This is the solution we propose, but we believe in the future maybe we will have more powerful or more robust solution. Maybe that's one of the solution we currently propose. Yeah.
Oh, I see. Thank you. And another question, if synthetic data and real-world data provide conflicting signals, for example, the simulator predicts improved throughput, but the real KPM show delayed throughput, how does RANPilot determine how much weight to assign to the synthetic versus the real data?
Yeah. Thank you for the question. Actually, this kind of new data is synthesized based on some essential external factor modeling. For example, the wireless channel. If we, for example, when we add a new cell, we have some physical relations about the UE mobility and the UE range and their relative range with the newly added or reconfigured radio unit. So for this kind of scenario, we can use a wireless channel model to bridge the gap between the new and between the real data and the synthetic data. And more importantly, in our evaluation, we find even if we use a simple wireless channel model or any kinds of the external factor modeling model, actually it's the success of the data synthesis is not determined by the precise wireless channel model, because what causes the data drift is the new network behaviors and like the radio control policies. So what's more important is to precisely integrate this policy and the policy effects to the synthetic data. It counts more than how precise wireless channel model is.
Interesting. Okay.
Yeah.
That's all my question. Thank you very much.
Yeah, thank you. I hope we can inspire our brainstorming, and maybe we can have future discussion and collaboration. Yeah, thank you for your question.
Okay, thank you very much. So do we have other questions from other pods?
If not, we can move on to the next paper.
Yeah,
Yes.
of course. Thank you, guys.
Thank you very much.
Thank you
you.
very much. Bye.
Thank you. Hope to see you next year.
I saw that Aoyu Gong has already joined, right?
Yes, we are here, and
Okay.
we will be happy to take your questions. So
Thank
just
you.
a quick self-introduction. I'm Aoyu.
My name is Rafael.
So we're both second-year PhD students at EPFL, and we're both the first co-authors of the paper SAGE, a real-time AI system for reducing latency in NextG cellular networks.
Yeah, good morning to everybody.
Good morning.
Sawadee ka for the people from Thailand.
Sawadee ka.
Swadika. Good morning.
Feel free to ask questions.
Như vậy ạ. Câu là bây giờ
It seems we cannot hear you.
Hello everyone. I'm JB from University of the Philippines. So I just
Hello. Hello.
Can you hear me? From Vietnam?
Yes, we can hear you.
Yes. Yes. It's nice to meet you.
Nice
So
to meet you.
I have a small question from the Vietnam Post. Okay?
Sure.
Can you hear me?
Yes.
Yeah. Well, I think the principle of the CZ based on the predictor. So we see the traffic profile. So how
Yes.
quickly can Saga detect a mismatch, trigger continue learning, and recover when UAE traffic suddenly change or before the previously unseen profile? So the question is exactly is when we are using a traffic profile.
Yes.
So yeah, some issue happen when we cannot see before. But yeah, we had not data before about the user profile or traffic profile. And how stone base in this case.
Did you get it?
I think we lost the last part of the question. If you can repeat.
Yes,
the
if
last
you can
part.
repeat, that'd be great.
Okay, I can repeat.
Thank you.
I know that is based on the predictor
Yes.
for the traffic profile. Is that okay?
Yes.
We
yeah,
check
traffic
this point.
profiles.
So for example, we cannot to see is the traffic profile before. That means unseen the user profile or the unseen traffic profile, and how to cancel this.
So if I understand correctly, you're asking if we have a new traffic, like a new application, traffic from new application join a network, what would happen? Is this your question? Sorry, can you hear me?
Yeah.
Is this your question?
Yeah.
So basically, in our current proposal, let's see, we kind of already have some traffic profiles in the AI model database, and if you have a new traffic, then we still will try to. So the near real time, we'll still characterize the traffic and form the statistical future for this new incoming traffic, and then we will get the statistical future vector of this traffic. Then we will compile this vector with all stored traffic profiles vector. And then we will measure which one has the smallest distance. And if we get the smallest distance, we will retrieve that corresponding model. And then we will use online continuous learning to adapt the model to this new traffic. Yeah, this is what will happen for new traffic.
There are more detail is, for example, when the traditional predictor, you can add more traffic profile very easy. So when you're using the AI or continue learning, and different time, just maybe make it too long. Just I want to know in this case is how comparison between the traditional predictor with the job proposed.
I see. So you're asking if we retrieve a prediction model for a new unseen traffic, then it may take too long to do the online prediction, to do this online continuous learning. This is your concern.
Yeah.
So you can see from our paper, we propose to use these multiple small models, very lightweight, very small AI models. So because they are small, when you do this online adaptation, it's very fast and efficient. We also show some evaluation about these micro benchmark in the paper. And also second, because now we'll retrieve a prediction model which are pre-trained on traffic, which is very similar to our current new traffic. That's why we are extract the vector, the statistical future vector of this new traffic, and then compare the similarity between all stored traffic profiles vector. And because these two things, the retrieval will be fast. And also, let's see, even if we do this online continuous learning, it doesn't work well, then we always continue to track the prediction error. So we will only use prediction model when we can trust the model. So let's see if we do this prediction, we do this continued track, and we found the error is high. So we will remain the users either in grant-free or grant-based access based on the slicing policy. Yeah.
Yeah, thank you very much.
Thank you for the question. That's a very good question. Yeah.
Hello.
Hand raised
Hi.
from UT of Indonesia.
Nice to meet you.
You will start Indonesia. You can ask a question.
I think I can hear you.
Okay, thank you for Ayu and Rafael for joining us today. Good morning. So actually, I have two questions for you guys. The first one is that about DRX, because we know usually the mobile device configured with DRX. Do you consider? Have you tried to consider the DRX during your predictions? Because I think like the DRX will significantly affect the prediction, right? And the device goes sleep and then up again, something like that. And what happened to your current prediction if it is considered in your model? And then know that we have so many traffic profile. I mean, like if I'm not wrong, like you consider like 10,000 traffic profiles. So I'm curious about how do you pick the best profile for each UE? And then how the latency for that? I think like I just concerned that the latency, like the selection the model selection will affect also the performance latency. Okay, thank you.
Thank you for your question. I'll take the first one, and maybe you can take
Yeah.
the other one. So regarding the DRX, in our test environment, the combination of discrete modems and our run choice, we did not have a DRX period for the UE because the UE was not on battery, so we didn't need to put it to sleep. So we did not consider it during our evaluation. But if you know that your UEs have a DRX period, since you are gonna send the grant in advance, you just have to pre-compensate for also the time to wake up the modem from the deep sleep state. Does that answer the question?
Okay. Thank you, Rafael.
Yeah, so I think the second question you asked is, let's say if we have a lot of models in the model database, how fast and how can we retrieve a model and how fast is retrieve the model, and maybe you also want to know the scalability of the retrieval. So regarding this, as we introduce the presentation, when you have a new traffic profile, we'll extract the statistical features, and specifically for each traffic profile, since we have this uplink data traffic, we consider two features. The first feature is inter-arrival time, and the second feature is arrival size. For each of these features, we will extract 8 statistical features, and then we have 2 separate vectors, and we will concatenate the 2 vectors into one final vector for this incoming traffic. And also, this is also the same for every traffic profile stored in the traffic-aware model database. So when we do the retrieval, we will compute the similarity between the like this online traffic vector and all stored traffic profiles vector. And then we will compare all of these values basically, and we will get the smallest value, which has the closest distance. So basically, we borrow the idea from this information retrieval system. It's like when you use Google, you submit your query, right? The Google will convert your query to a vector. And then it also have a lot of documents in this database. And it will compare the query with all of these documents vector. And based on this distance matrix, you retrieve the document which has the smallest distance. So our idea here is kind of similar. And regarding your second question, how fast is this retrieval? So we did a micro benchmark on a mini PC from Intel. So we can retrieve a prediction model with, so let's see if your database have 10K models, 10K traffic profiles, we can finish the retrieval by extract the traffic features and compute the similarity matrix and retrieve the model within 0.2 seconds. And also we can handle 50 concurrent queries within 1 second. And it just on a very small like mini computer. So let's see if you have a more powerful computer, you can even do like with more concurrency. Yeah, I think it also answer your maybe the concern about the scalability. Yeah.
Yeah. Thank you.
Thank you for your question. Yeah.
Hello. It's
Hello.
JB again from University of the Philippines.
So
I just have
sorry,
two
I feel the sound is a bit low. It's a little bit low. Yeah.
Okay, I'll try. Is this better?
It's better. Thanks. Yeah.
Okay.
Nice.
Okay. So I just have two questions. So first, does it matter, or did you notice any difference? Because I understand there's a lot of abstraction already on the traffic patterns, right? But
Yeah.
like for example, on the physical configurations like FDD or TDD or the subcarrier spacing, would there be an impact or a difference on on how SAJ will perform?
Yeah.
Very good question.
You want to take this one? I can also handle.
Yeah, go ahead.
Yeah. So basically, So basically, the key reason we propose this new abstraction traffic trend is also want to like overcome this like diversity from not only system dynamics, like from scheduling, resource contention, and it also from different system configurations. So if you see our evaluation, we also evaluated SAJ on the system configuration from two national commercial operators, and they are using different TDD patterns, and also we're even using a different like the channel bandwidth, and we don't need to retrain the predictors, and we can directly apply a pre-trained model on different like the system configurations. That's also the key reason, the key motivation we want to introduce this concept of traffic trends. Yeah.
Okay, thank you. For
Yeah.
my second question, so I understand that you did experiment up to like 10 UEs, right?
Yeah.
But and it's only exclusively for like the LLC, UR LLC use case. Is that correct? Now, did you actually try to like, or would you know what would happen if you reach like a saturated point where all resources are used up? So what will happen for that
Yeah,
case?
so
Like so many UEs or whatever causes for the resources to be used up.
yeah, this is a very good question. So it depends. So Sage predicts the arrivals for the UEs that are in URLC and that need low latency, but ultimately uses the same underlying scheduler that you have in any 5G base station. So I think in the paper we have a round robin and proportional first scheduler, but you can imagine putting in any scheduler that you might like or you might want to experiment. And so if you saturate the bandwidth and you have more requests than the bandwidth, the scheduler is going to have to make some choices. So either it's going to throttle the UE's throughput, and so it's going to reduce the throughput of all the users, or it might prioritize some users that are in a maybe higher paying slice or in a more like in an emergency slice that need to be prioritized. So I think this is going to come down to how you set up your scheduler and how you decide to share the resources among the users when you have a request that is higher than what your bandwidth can support.
Yeah.
Oh, thank you. I think we have one more question here.
Yeah, sure.
Okay, am I audible?
Yes.
Nice to meet you.
Hi, I'm Paul from the UP. So another question that I'd like to ask is that I read your paper and it said that you guys made your own RT rig and your near RT rig, right? So may
Yeah.
I know if these are, let's say, are these the ones provided by the Open RAN software community, or were these built built by you guys?
Yeah, thank you for your question. So unfortunately, when we started this project, we couldn't find any real-time rig or near real-time rig that satisfied our requirements, and so we went ahead and just wrote our own controllers. They are not sophisticated and they are not production ready. We just wrote some piece of software that lived alongside the run and would just execute live and fulfill the request from the run. So it's they are not based on any existing rig, and they actually perform just the bare minimum functions that the paper needed.
Yeah.
Okay, thank you. So in addition to that as well, so when it comes to network slicing, so your guys' focus is on the low latency slice, right? So when it comes to actually implementing your experiments, were you able to emulate UEs that had, let's say, more than one network slice connected? So let's say as you mentioned, some applications are connected to the low latency slice. There might also be some other applications also on, let's say, the high width slice. So was this considered, or did you do any experiments on this, or how did you implement it?
Yeah, good question. So this was definitely considered, but we were not able to achieve, we were not able to implement this. So we know that the 5G standards allows Aoyu to open up multiple virtual links to the base station, multiple DRBs that can be assigned to different slices, and different slices might belong to low latency, eMBB, general traffic. Unfortunately, due to the hardware and software that we had in our testbed, we were not able to simulate Aoyu with different slices, with different applications belonging to different slices. What we did was to have every UE belong to a single slice, and so we had background traffic generated by other UEs, not by the same UE. But we think that thanks to the isolation that can be done with DRBs and slices, we think that it would be the same even if the background traffic came from the same UE. It's just that we were not able to open multiple PDU sessions to different applications to the same UE. But I think this is something very interesting that somebody should look into it and try to replicate this experiment on the same UE.
Okay, thank you.
Thank you.
Thank you.
There's a question from Bangkok participant.
Hello. Yes.
So,
Hello.
what is the circumstance that SaaS might not provide a significant advantage? And there's what is SaaS fallback mechanism when the prediction is not correct?
So basically, you can see the whole system design of Sarge, we have 5 components. So by default, the fallback will based on your slice. So let's see if you have a best effort slice, the default access mechanism is grant-based access. Then if we found that we continue to track the prediction error, it's high, then we'll just use a default access mechanism like grant-based access. And if you have a low latency slice, which by default you allow some grant-free access, and if we found the model does not perform well, then we will fall back grant-free access. It based on your own choice. These fallback mechanisms. Yeah.
And I think the other part of the question was when does SAJ not provide a great advantage? I think is all those applications that are very hard to predict. For example, I think we noticed that Zoom, whenever the channel was varying, Zoom does some very elaborate adaptive bit rate, which changes the pattern of the traffic very much, and to which SAJ was simply not able to predict. So either you need a more a smarter model, which maybe it's deeper or bigger, or you just accept that some applications cannot be accurately predicted, and so you have these fallback mechanisms that, as my colleagues mentioned, can either be grant-free or grant-based based on the strategy or the policy that your slice has.
So because if I can add one more point is because I think it's very important to know how to organize and use AI and how to use AI safely for next generation cellular networks. So I think it's very dangerous directly like plugging AI and then we directly use output, apply the output to the scheduling or whatever. So we must continuously, like in our SAJ, we must continuously track its prediction error. And we only use model when we are sure that we can trust the result. Yeah. That's why we have these fallback policies, fallback mechanisms. Thank you for your question.
Okay, thank you very much. Thank you very much for the answer.
Yeah.
Okay. Is there other questions related to Sage paper?
I think we have some questions in the chat that we didn't see.
Yeah. So the question is, since continued learning uses the most recent traffic trends to update the model online, how do you prevent the model from adapting too aggressively to temporary traffic changes and forgetting the original traffic patterns? So here, I think again, as we mentioned, so we are continuously tracking the prediction error. So then if let's say the traffic application really change very fast, then we use this online learning adaptive model to that behavior. And after a while, the traffic behavior change back, then you may get a very high prediction error. In that case, we will not use a model. And also second is, so we train a model to learn the behavior from one application. So ideally, you should get as much as data from this application, which can cover as many as its behaviors as possible, so that we can just train this AI predictor for this specific application. That's all. That's also the reason why we propose to use these multiple lightweight expert AI models, because you have one X model just learn different behaviors from that one application. And also, another thing is, so from the traffic profile to predictor is not necessarily one-to-one mapping. So it's not just one traffic per vector index one prediction model. One prediction model can be also indexed by several, let's see, 10, even 10, 20, like these traffic profile vectors. So it can cover a lot of behaviors from a single application. Yeah. Thank you for your question. Thank you.
Okay, thank you very much, maybe we can move to the new paper, and then
Yeah.
if we have time, we come back to you to both of you later.
Yeah.
Okay, then I just want to say that I'm very glad that all of you could join and ask questions. We like your interaction, and I hope to see all of you guys next year.
Next year in Bangkok.
In Bangkok with the Southeast Asia.
Yeah.
Oh, you already know that. Okay.
Yeah.
And also, if you have some follow-up question or some other questions, feel free to send us email.
Of course.
We're happy to chat and keep discussing. Yeah. Thank you so much.
Bye.
Thank you.
Bye.
Bye.
The next paper is the near optimal online traffic engineering by Arvin Ghavidel. Are you here, Ghavidel?
Yes, I am. Thank you for having me. Hopefully you can hear me correctly, right?
Yes, we can hear you. So maybe I can start the questions. Hi, Arvin, I think we met at USC. I'm not sure.
I don't think.
Sucha, yeah.
Oh, Sucha, it's you.
Okay.
Oh, I didn't recognize. I don't think we've met, but I've definitely read your paper, and I've been working with Purya a lot.
Ah, you work with Korea. I see. Yes. Yeah. So I read your papers. Very nice paper that you apply the ADMM to do the distributed traffic engineering. And actually, my question is kind of like a high side question, because you do all the math and then you break it into like the algorithm, distributed algorithms. But it seems that you didn't. You didn't follow like just a pure like strawman approach, right? You did the nested ADMM, you apply the SVM to reduce the computation. You also do the partial barrier asynchronous technique. So
Yes.
those are not actually like a straightforward way, but it is probably because you stuck at something and then you have to come up with all of this way, all of these things, so that you can make the algorithm work in practice. So my question is like, for PhD student here, like how do you map or how do you come up with the solution when you like apply the theory? How do you come up with a solution that works for the theory and practice at the same time?
I mean, that's a high-level question. I hope I knew a good answer for that, because that would make my life easier. But I can sketch for you what happened specifically for this paper. So the idea of applying ADMM for TA, this isn't new. There was some related work that already done it. In particular, the main related work that we consider is a work called DD that appeared in OSDI, and that work did ADMM. And I was interested in that work, but when I looked into it, I started to have some problems with the way that they did it. And me trying to kind of iteratively solve those problems was the thing that, had me introduced the nested ADMM stuff and the benefit of asynchrony, for example. So the main theoretical base was already there, but it had practical limitations. So us trying to kind of move around those practical limitations was the main motivation that we ended up with all of these. Now, of course, at some point we couldn't do ad hoc solutions, so we actually had to change a lot how the original decomposition of DD actually worked. And the core is using ADMM, but the decomposition is completely different. So it was a very iterative process. We didn't come up with the theory first and then try to like make it more practical. We had to do it kind of jointly. And on the practical side, another related work that was really important for us was the DSDN paper from Google, because we draw a lot of our practical considerations directly from that paper. So for example, the part that we claimed that programming the switches from a remote node is difficult, which motivates for us to have a distributed setting in the first place, that's an observation that first came from that paper. And we actually knew about that when we were working on this. So when we knew that, we started to like change how the theory works even more. So yeah, I don't have a simple answer to your question, but I can say that it was a very iterative process that you had to do jointly. You couldn't do one at a time.
Okay, thank you very much. Thank you very much. Okay, maybe I move to the other parts and then yeah, thanks.
Yeah, so one question from Vietnam. Yes. Yeah, I think this, yeah. Can you hear me? Can you hear me?
I can hear you. I'm not sure if my voice is coming through.
Can you hear me?
I can hear you. Like, can you hear me now? Maybe?
Yes. I have a small question for you, right? So during the rapid the successive traffic chain of value, how does the system guarantee the speed quality if the conversion cannot complete before the next event?
I lost your question. Can you repeat slightly again?
Yeah. During the rapid successive traffic chain of value, that traffic that maybe is fluctuable. So how does the system guarantee the speed quality if the conversion cannot complete before the next event? So the conversion time just maybe make it too long. So if the traffic chain or something a failure in the system cannot to guarantee the service quality. Yeah.
If I understood your question correctly, what would happen if the system isn't able to converge in time?
Yeah. The conversion time just maybe too long more than this the time slot happen between the two events.
Yeah,
so
okay, that's a good
out of the system.
Okay, so the way that our implementation currently works is that there is a nominal time slot of around 20 seconds, and we're doing a recomputation every seconds or so. Now, you can certainly have cases in which that isn't enough, in which you do not actually converge in time. And when that happens, you have to make a decision. In particular, you have to do some sort of a projection on your solution to make it feasible, and then warm start again for the next iteration. So that's currently the method that we do. So the main thing to be smart about here is how do you do that projection? And the projection that we are using is actually very simple. So if you're in a path-based setting, what we do is that we just scale all the total of the numbers such that we don't violate the capacity constraints. But obviously, that might end up leaving demands unsatisfied. And we do this because in practice for WANs, congestion is more worrisome than leaving demands unsatisfied. Because when you have congestion, throughput for many flows collapses. Rather than if you leave demands unsatisfied, it's only those demands that are going to be hurt. So in the edge-based setting, things are slightly more complicated. In the edge-based setting, you have to take your current edge-based setting and do some sort of an overnormal projection that brings it into a feasibility set. The details are in the appendix of the paper. You can certainly look at that. But yeah, in general, if convergence doesn't happen in time, you have to make some sort of a compromise and then warm start again. And hopefully in the next iteration, you'll be quick enough to converge. There are actual examples of this. If you look into the paper, in particular, we have this trace where we're comparing against DD, and you can see sometimes where online T doesn't really reach the optimal solution, and then it stops and then reiterates in the next time slot. So those things definitely happen, but the important thing here is that the errors don't compound. So it's just the fact that it takes a bit longer to converge, but convergence still happens.
Yeah, thank you. Thank you.
Yes. Okay, we have another question, I think.
Yeah. I have one question, Arvin. So actually, I want to ask about the convergence of your algorithm. So actually, based on your paper, you assume for the regularity. So I just want to know whether this assumption still hold in the real situation.
The assumption about what?
The regularity.
Oh, the regularity. I mean, that's you mean the regularizer that we add into the optimization, right? So there are a few things about that. So in the path-based setting, you don't actually need it. That regularizer is an artifact of us trying to improve convergence and to have certain nice properties. In the path-based setting, that regularizer doesn't do anything really. It only aids convergence, and it's a teeny tiny quadratic term. It really doesn't change the objective that much. But in the edge-based setting, that regularizer is important because it actually helps you prevent loops. Because when you move on to the edge-based setting, it's actually possible for the optimal solution to have loops. And you don't want to select those solutions, so the regularizers actually select for solutions that don't have loops. So to answer the question, that doesn't change the optimal solution, but it helps you converge to good solutions.
So how do you know then your solution goes to the near optimal, for example?
I mean, again, this isn't really an assumption. Like when you add that regularizer, the optimal solution doesn't actually change. It's something you can actually easily show. And I can give you a simple example of that. Again, like think you have a solution that has some loops in it. It's very easy for you to find a cycle and see what the smallest flow is and drain it so that you remove that cycle, right? So if you have an L2 regularizer or even a linear regularizer, that's exactly what happens. Because if you converge to a loop solution, the regularizers have a higher value, so the optimizer is incentivized to lower them. And it does exactly that.
Yeah.
There is one case though where the regularizer does change the solution, and that's again for the edge-based case where we are doing sparse solvers. In that case, what we're adding is that we're adding this L1 regularizer, and that does change the solution, but that's something that we actually want because when you do that, you get solutions that have less number of paths, basically. So yeah, so it's optimal in the sense that the final result of the algorithm has optimality gap that's less than 1%. But what notion of optimality you want, well, that depends on the problem. In an edge-based setting, that's not the true optimal, but the true optimal has like many paths. That's just not practical.
Yeah. All right. Yeah, got it. Thank you, Arvin.
Okay, there is one question in the chat that I will read. So they say, although NT distributes optimization across switches, it still relies on central coordinator. What happens if the coordinator fails or becomes unreachable? Could it become a critical failure point of the system? Well, it can certainly happen if you do it in a naive way. But the good thing about NT is that the coordinator doesn't really do that much of a computation and has very little states. In fact, we don't have this in the paper, but you can come up with one version of R90 that actually has the coordinator right on the switches for every switch in the network, because it really doesn't do that much of a computation. So it's very easy to have multiple coordinators that back up each other. So if one fails, you can quickly roll back to another one. So that's the mode that we assume that we can have failures predicted on the coordinators, be that either regional coordinators or the global coordinators. Really, the main failure case that's of worry for us is failures in the data plane, either in the links or the switches. And the reason that we'll be worried about that because they change the properties of them. example of that in the paper that you can actually see. So failures on the coordinator, we think it's possible to handle them because the coordinator is really, really tiny and small. You're welcome. Okay, one other question.
So do we have questions from University of Philippines?
Hello, hello.
Oh.
Hello.
Hello, I can hear you.
Marlo from UP I'm just curious, what happens when the network changes faster than when online TE can converge? No? Is there some kind of theoretical bound on how far the system solution can deviate from, let's say, optimality under, let's say, a continuous changing traffic demands under multiple failures? Because in real life network, there are multiple or hundreds of failures happening in a system. Can you share at least your experience, or if you experience that kind of scenario?
Okay, so I think I picked two things. One is failures and one is changes in the network as in the demands, you mean?
Yes, yes.
Okay, so for failures, you can, I mean, we don't have it in the paper, but it's very easy to bound and see how much the solution becomes bad. But that bound kind of lies to you because it assumes that you can still forward traffic on a dead link. And you probably don't want to do that. If you want to come up with a bound that is in the feasibility set after the failure, it's going to be probably kind of difficult. The only thing that we have is that convergence eventually happens, but about what's the bound on that, that's a question that we're looking at. As for demand changes, what you're asking is actually a very, very good question that's kind of on the mind of both me and Nick, because as fast as online TE is, it's not truly online because in a 20-second interval, demands can change a lot still. I don't have a concrete answer for that, but I can tell you one thing, and the fact is that if you want to maintain TE, as in this abstraction that you have demands that come in and you just recompute, you can't make that time interval too small. And the reason that's the case is because in a real WAN, when TE does something, congestion control reacts. So if you're looking at like really, really tiny time intervals and solving for that somehow, if TE does something, congestion control changes the demands in the next iterations.
Yeah,
So
it's
there is
already a new state.
correlation between them. And if you reach that regime, I have no idea how things would look like. And that's something that has been in the mind of people doing networking for a long time because there has been these line of work that are actually quite old that we do cite in the paper that do truly online traffic engineering. That is traffic engineering that is indistinguishable from doing congestion control, basically. They're doing it at the same time. And that sort of work is really, really difficult to control. It has no optimality guarantees, from what I understand. They are, at the end of the day, heuristics, but they're also so sensitive because there's this loop that's changing the demand splits change how the demand look like in the future. And from what I understand, no theoretical work has been done on that front, which is exciting because we can come and do it. But I don't have an answer for you on that front about what happens when you go into that scale.
Thank you. Thank you.
We have a question from the Thailand part. Okay. From my understanding, you mitigate the straggler effect using the hierarchical ADMM loop by splitting into the different regions based on the geographical location. I have two questions about this. The first one is, if we split the based on the region based on the geographical location, does it introduce the other kind of heterogeneity? Like one region might have a different kind of traffic demand than from the other region. And my second question is, does this heterogeneity affect the convergence of the overall ADMM loop?
That's a very, very good question. That's one evaluation that we should probably look at a bit more. So because we've been using synthetic traffic matrices, that's one part where our evaluation is kind of weak, to admit it. So because in practice, traffic matrices are very, very lopsided. So that's actually a good concern. What I can tell you is that on paper, the global coordinator should be able to handle it because the global coordinator can already assign more capacity to a particular region if it's required. So if you have more demands within a region compared to another one, the global coordinator is able to account for that and gives more demands, more capacities to that particular region. But we don't have an evaluation in the paper that addresses that correctly.
Crap.
Well, thank you, Arvin, for your time. Thank you so much.
Yes, thank you for having me.
Yeah, no. Yes, another author is waiting. Ayush? Yes,
Yes, hi. How is everyone doing?
good. Yes. We couldn't hear you, Prishai.
Okay. I have a question from Bangkok. I'm Prishai. You are like you are transmitting the screenshot of the web page to the user, right? But I have a question that is it better to transmit the text or anything like the text like that will be smaller for transmitting via the radio?
Yeah, that's a very good question, actually. So by text, you might mean, let's say, Markdown or HTML, for example. So the difference between so we considered this and we found that if you just transfer HTML through WebFM, what happens is you are going to be sending the HTML code, but at the same time, the images and other resources that are required to render that page also needs to be sent to the end user. And oftentimes, these all resources combined are megabytes long. So I'll give you a scenario where a web page has a lot of text and maybe 3 images. So if we are sending each resource separately, like we send the text as the HTML markdown, and then we send other images. What often happens is that it will take a lot of time through the limited data rate that we have. So if we compress it to one single image, it's going to be a lot faster. And that's why we're using screenshots.
Okay. Indonesia port has question, please ask.
Okay, yeah, this is from Indonesia. So I know that for the modulation you use OFDM, like I think
Mhm.
one of because you want to have a high data rate to that for that. But at the end, based on the exit survey, actually, we know that like a lot of user like doesn't really, I mean, satisfied with the reliability issue. I mean, like there is a reliability issue in the system, but I think the main reason because we are sending a list data like web page, something like that, using a broadcast. We don't have a retransmission in that case. So have you tried to use a more robust modulation like QPSK for your system to also I mean solve the reliability issue? That's for the first question. And the second one is actually about the like is there any way to support like a unicast instead of a broadcast transmission for using this FM radio? Okay, thank you.
Okay, so the first question about the modulation scheme, why using OFDM? We actually tried with a bunch of all available state-of-the-art modulation schemes, but the problem here is that we need to balance between what can be sent and what can be decoded at the end receiver, right? So while using OFDM, the quality of the audio and the encoded audio was basically clear enough for the end receiver on the Android phone, where it was able to kind of decode the transmitted data properly. And that's where we saw a balance with 92 subcarriers while trying all these different sets of modulation schemes while increasing and decreasing subcarriers as well. That point was basically where we reached the highest data rate, which was the 10 kbps data rate that's on the paper. Regarding your another question, can you quickly remind me what exactly was the topic?
About the unicast, I mean, like instead
Yes.
of like broadcast transmission.
Yes. So unicast is with FM transmitter is not possible. But you can kind of go around and do encryption basically. So you could encrypt, you could do an enrollment during your first installation with the user and then save their private key at the server. And then you could essentially broadcast it, but then only the end user that is supposed to receive that will be able to decode it. So in that way, you can kind of go around and kind of make a case for unicast, but otherwise
In
with
case
broadcasting.
like we have a lot of overhead for the data, right? Like
Exactly.
because we have
So all the other devices are essentially caching the data that they really don't require, right?
Right. Okay. Thank you, Ayush.
You're welcome.
Hello, can you hear me? I have some questions.
Yes.
So basically, in your paper, you say that you are modifying the default FM, right, or application to support your application, and then you say that you have to modify it, or either the manufacturer can provide your application directly, right? So, but you also say that mostly your target is cannot access the internet. So I want to ask you about idea. How do we what is the first step to adapt your application? Since it's require software update or maybe built into the manufacturer.
True. So our solution is solely based on making deployments easier. So we currently you cannot just download an application and run it on your phone. What has to happen is a collaboration between manufacturers. So manufacturers could send a software update for their device to update the logic based on our implementation, or any low budget smartphone application could actually design the system from the start so that they implement the sharing of FM radio streams to the user space applications. And that would be a case where you could deploy as without even changing anything after you purchase the phone. But if you are an NGO or an INGO who wants to deploy at a location and you have a bunch of phones that you already have, what you could do is you could flash those phones with this new operating system, and it'll start running using the solution that we provided.
Okay, thank you.
Welcome. I think I see a question in the chat. Operation with a high volume of SMS acknowledgement traffic let the mobile operator block all deployed SIM cards. Proposing encrypting SMS payloads to mitigate the privacy risks associated with the plain text transmission. How do you plan to implement this encryption without triggering for the carrier level blocks or automated spam filters? That's a very good question, and that's something that we also kind of thought about, but at the same time we did not test it. That's why it's in the discussion section of the paper. But the idea here is that we need to shorten the amount of SMS messages that we're sending. If a server is sending, or if all phones are acknowledging the received partitions, then the number of SMSs sent by all these phones are going to be way large. But at the same time, if we do encryption, we're encrypting only the requests. So you're encrypting basically what your custom URL request you want to access, and what kind of LLM prompts you want to ask. So that number is significantly less than the blocking limit that we found, or that we encountered when we wanted to get acknowledgements from the end users. But I agree that the SMS provider might flag this as a spam, but we have not actually measured it. We need to measure it to give you a conclusion on that. But yeah, that's a very good point.
Okay. I have another question about how do you like determine what content to broadcast? Like in your paper it is like popularity, right? But how do you determine about that? And another one is will your work be actually deploys and provide the service somewhere?
So the first question about how do we know which popular pages to transmit? So there are a lot of metrics and a lot of websites like Alexa ranking, Amazon ranking, and there is Tranquilist, from where we extracted the popularity of these pages from that should be served in the region. But we also open it to customizable for an operator or an FM radio station that wants to use the system. So placing the system in Africa versus placing it in South Asia or East Asia is going to be completely different, right? It also depends on what kind of popularity metrics you want to incorporate to make that list. We show in our paper, the scope, it goes a little bit out of scope, because we kind of propose that as soon as you have this list, you can actually run the system technically like this, but you are open to use any sort of metric to determine that popularity. And popularity would be not just for news, it would also be for any other type of content, like blogs, for example, or government announcements, for example. So that is a customizable property of the system that an FM radio operator or any person who is trying to deploy this in their country or region would be able to customize. Then another question about, do we want to extend it? Yeah, we are interested in actually learning the impact of this in long term. So we were actually planning to collaborate with a couple of non-government organizations where they could deploy the system in a region where there is complete cutoff from internet, and the geographical terrain is so complex that even when there are cellular towers, it's not usually very effective. And what happens there in extreme weather conditions is that they are not able to run their schools. They're not able to, their schools are shut down for a long time. So what we were thinking of doing is that we give the system to students in that school. They would be at home. They would kind of use the system for 6 months, and then we try to see what the impact of it is for the students. that is more of a social science kind of study, looking at the impact of the system. But technically, we are thinking of extending it to also support ultrasonic transmissions. So a bigger limitations, limit of the system is that whenever there is a WebFM transmission, the regular transmissions are blocked because you're essentially using the same frequency, right? And the frequency that we use for encoding with OFDM is within the audible frequency. So what we could do potentially is that we would have the regular transmission, and also in this other frequency, we would have an ultrasonic frequency where the OFDM data is encoded. OFDM is used to encode that data. So essentially, you could transfer the whole audio where there are two different layers of information. And on the other side, when the phone tries to decode data, it would only look at the ultrasonic frequency. And while the FM radio transmissions are running, it could potentially decode all the web content or LLM responses. So that's sort of a future kind of technical work that we wanted to do. We tried, but we did not succeed the first time. But potentially in the future, if we have somebody who can work on more of a physical layer, we will probably be able to do it.
Okay, thank you. Any question from other pods? Oh, there's.
I see a question from Thailand. Have you done a real cost per user comparison between WebFM and 4G or 5G? Yes, we did. We took our Cameroon experiment as cost per comparison between cellular and WebFM. So in Cameroon, for example, you could potentially buy a package for $14 per month, but you would essentially get very low speeds and not a very good quality of experience. But if you use WebFM, it's essentially, as a downlink user, you're free to use. There is no money involved. But if you want to use the SMS uplink, you would have to pay $1 or $2 just to send those custom requests. And you can send as many requests as possible, unless your telecom operator blocks your request, which rarely happens if you're only requesting content and you're not acknowledging every frame that you received. So essentially, there is a difference between paying $14 versus paying $1 for the entire system. Yeah, I hope that answers your question, but yeah, do let me know if you have any follow-up. You're welcome.
Okay, I think we have to wrap this up, right? Because it's a little bit over time. Thank you very much, Ayush and Arvin and other authors who probably left already, for taking your time to help us, help answering questions for researcher and student back in our Southeast Asia. Thank you so much.
Thank you so much for inviting me. It has been a good experience. Thank you.
Same here. Thank you.
Thank you.
Thank you very much.
Okay.
Bye-bye.
Bye.
Take care.
Thank you. Okay.
Okay, bye-bye the other side.
Oh, wait. I think
Oh, do you have something else for
a group photo or something?
I took a snapshot from time to time, but Kankanpat just turn on your camera, right?
We will have a recording upload to YouTube.
Yes.
Okay, and for the other pods, I'm not sure whether do they know that next year SIGCOMM will be in Thailand?
Yes.
Official. I mean, sorry that I like telling them.
No, great. It's great. Please, next year SIGCOMM will be in Bangkok, so we would love you guys to be on site at SIGCOMM to experience the real conference with the full conference. If you could come, there will be announcement on the student grants that the student can apply to come as also a volunteers. Once things are already set up, the announcement will be made, and Prichai will probably send you all on this information. Thank you.
Yeah, hopefully see of you people from Philippines and Indonesia in Thailand next year. Okay, bye.
Bye.
Bye. Thank you. See you next year.
Okay.